Good morning, everyone, and welcome back to our geography lesson once again. I hope, children, you had a safe and healthy vacation. Now, before the vacation, I taught you three chapters: Earth as a planet, then geographic grid, and chapter on volcanoes. Now, chapter 1, that is Earth as a planet, has been removed from your syllabus. So, you will not learn that chapter. And I have also uploaded the syllabus for half yearly, so that from time to time you can keep consulting what are the chapters that I have to teach you and what you have to learn. And today I will be teaching you chapter 3, that is Earth's rotation and revolution. Now, in the beginning, you will see that there is a syllabus given and we will stick to this syllabus. I have uploaded the pages of the chapter for you to follow while I'm explaining. So, let me start explaining the chapter. Now, in the first paragraph, you just underline, I've made a bracket, that the earth rotates on its axis as well as around the sun. And these two motions of the earth is known as rotation and revolution. So remember, the two motions of the earth are rotation and revolution. And because of this rotation revolution, a lot of phenomena, changes and climatic changes take place on the earth. Now we come to the first motion, that is the rotation of the earth, and I have underlined the definition. So you learn this definition, that rotation is the spinning of the earth on its axis from west to east once in 24 hours. Now you will see the diagram which is showing over here. It is showing you that the earth's axis is not straight, it is inclined. So the earth spins on its axis, and when it moves on its axis, it takes 24 hours to complete one rotation. So that is all you have to learn in the definition. Now, below that is given the characteristics of rotation. And the first characteristic is the direction. The earth completes one rotation from west to east on its axis in 23 hours, 56 minutes and 4 seconds, approximately 24 hours. So remember that the direction the earth rotates from west to east in 24 hours. Second characteristics of rotation is inclination of axis. Inclination means that the earth is not in a straight position. If you see the diagram here, figure 3.1, the earth is tilted, and you will see a vertical line in dots, in dashes. This is the vertical axis, but the earth is not vertical, it is tilted away from the pole. Now this angle at which the earth is tilted is called the inclination of the earth's axis, which I will explain you later in the chapter in detail and its effect. So the second characteristics of rotation is that the earth is inclined at a certain angle. Then the third characteristic is the speed. Now when the earth rotates, the speed of earth's rotation is maximum at the equator, that is 1670 kilometers per hour. And this speed is covered in 24 hours, and as one moves away from the equator towards the pole, this speed goes on decreasing. So this is the characteristics of the rotation of the earth. Now we come to the effects of the rotation of the earth. Now the first effect they have given you is the occurrence of day and night. Now they have written over here that this day and night occurs because while rotating, one half of the earth faces the sun, so it experiences day, and the other half, which does not face the sun, experiences darkness or night. Now this picture over here will make you clear that the earth axis, you can see, is inclined. North and south it is given here, and you can see the part which is facing the sun is having day, and the other part which is not facing the sun is experiencing night, because the earth is round in shape, or you can say it is spherical in shape. So the first factor is that rotation of the earth causes day and night. Now, the second thing they have written in the text is the sunrise and sunset, which is also caused by the rotation of the earth. This happens because due to the earth's rotation, every part of the earth's surface faces the sun at some time or the other. So the part of the earth that moves from darkness into the sun rays experiences sunrise, and when it moves away from the sun rays, it experiences sunset. So when we see sun rays, or when there is brightness, then it shows that the sun is rising, and when it becomes a little darker, then it shows that the sun is setting. Now, the third important effect of the rotation of the earth is the Coriolis force. Now, Coriolis force or Coriolis effect, they have written over here, refers to the force experienced by any object moving over the surface of a rotating body such as the earth. This means that earth, when it rotates, it creates a force which is called a Coriolis force. Now, this Coriolis force or Coriolis effect is very, very important, because it changes the direction of the winds and the ocean currents moving in particular direction, because these winds and ocean currents cannot cut the force of the earth, so their direction changes, and that is why it is called the force of the Coriolis effect. And they have given here, due to its effect, that is due to the effect of Coriolis movement, the winds and ocean currents move clockwise and are deflected. They change their position to the right in the northern hemisphere, and they move in the anti-clockwise direction, and their position is deflected and changed to the left in the southern hemisphere. So the Coriolis force, which occurs due to the rotation of the earth, changes the movement of the winds and the ocean currents. The next point is that the sun, the moon and the stars seem to move from east to west, because the earth rotates from west to east. Now, fifth point is the centrifugal force. Now, again, when the earth rotates, it creates a force, which is the Coriolis force or centrifugal force. Now, this force, where one side is changing the direction of the winds and the ocean currents, the other side gives the shape of the earth. It is bulged at the equator and flattened at the poles. So this is the effect due to the rotation of the earth. Then rotation causes difference in time. We know there are 360 longitude, and the earth covers all these 360 degrees of longitude in 24 hours. So at every 1 degree of longitude, the sun shines for 4 minutes. So there will always be a difference in time as the sun changes its position from one longitude to the other. So these are the 6 major effects which you are going to learn. Now, the next topic they've given you here is the inclination of the Earth's axis and its significance. Now, this is what I was just explaining previously when I was doing the Earth's rotation, that Earth is inclined, it is tilted. So, here they have written in the 4th line, which I have underlined, the Earth's axis is not vertical, it is not straight. It makes an angle 23.5 degrees with the vertical, or 66.5 degrees with the plane of the Earth's orbit. Meaning to say that the Earth's axis is not vertical, it is inclined at 66.5 degrees. And you will see in this diagram, I've tried to show you through this diagram, that you will see the axis is vertical, and from the axis, the Earth is tilted away 23.5 degrees from its axis and is inclined at 66.5 degrees. So this inclination of the Earth's axis is called the inclination of the Earth. So it is not straight, it is inclined at a certain angle. And because of this inclination, again, there will be a lot of effect on the climatic conditions on day and night on the earth. So here they have mentioned, now you will see some portions I have cut it out. So you don't have to learn that. Above that, they have given you a diagram showing an inclined axis, which I have already shown you in a diagram earlier. Now we come to the effects of the inclined axis on the duration of day and night. So when the Earth's axis is inclined, the duration of day and night is not equal at all places. You just learn this much because there's a detailed explanation when we will be doing seasons. And because we will be doing the change in seasons due to revolution of the earth, you will come to know how the change takes place in day and night. So day and night is not equal at all places. Then the time of the day at any place is determined by the sun shining on a particular longitude in the sky. If the axis of the earth was vertical and it was not inclined, then all the places on the earth would have had the same temperature throughout the year. So it is not the this fact is not there. We don't have the same temperature throughout the year. All the places experience different temperature at different part of the year. If the earth did not revolve around the sun, even then with its inclined axis, there would be no seasons. If the earth did not move around the sun, then no seasons would have occurred. Now again they have mentioned you here effect of the inclined axis on seasons. And we've already done here that there is unequal length of day and night, lot of climatic changes take place, the time duration is not the same. Now the first thing that they mention here is the path of the earth around the sun is elliptic. Elliptic means it is oval in shape, it is not round. And the earth's axis is not perpendicular to the plane of elliptic, but it is tilted at an angle of 66.5 degrees. So they have repeated the same thing, that the earth is inclined at an angle of 66.5 degrees. And again I'll be explaining you through the diagrams. Now don't learn anything in detail because it's a repetition of what we are going to do later on. Now in this green index they have written, why do we not feel the motion of the earth? Rotation and revolution are the two chief motions of the earth. If we were to feel these motions, it would make life uncomfortable. So we don't feel these movement. Why? Because the force of gravity keeps everything attached to the earth. This keeps all the objects at a rest or motion with reference to the movement of the earth. So if they ask you, this much is the answer which you have to write. You don't have to mention the principle and Newton's first law of motion. Now children, this diagram is showing you the sun in the center. The orbit of the earth is elliptic, that is, it is oval, which I just explained to you a little earlier and read to you, and the earth. And you will see that in this diagram, the earth in one way is going to move around this sun. So the movement of the earth around the sun in its orbit or in its elliptical orbit is called the revolution of the earth, where we did the rotation on its axis. This is not on its axis, but it is around the sun. So this is the definition, that revolution of the earth is the movement of the earth around the sun in an elliptical manner or around the elliptical orbit. Now this is the diagram they've given you. The definition is given here. Now let's study what are the characteristics of revolution. The earth moves around the sun in an elliptic orbit at an average speed of 29.8 kilometers per second or about 100,000 kilometers per hour. Then they've said, the last line, the speed of revolution is not uniform. No need to learn anything, only this line. The third point is also important because there is one question that will come out from it, that what is a leap year? Now we know that when the earth moves around the sun, it takes 365 days or 365 days 6 hours. Now this 6 hours every after 4 years is adjusted and it makes one complete day, and that year is a year which will have 366 days and it will be called a leap year. So revolution also is responsible for leap year. And the fourth point is the earth's axis is always inclined to its orbital plane at an angle of 66.5 degrees. So again, this is the repetition, that the axis is inclined and the motion of the earth from west to east or in the same direction as the rotation. So you just learned that the axis is inclined at 66.5 degrees. Now children, we come to the effects of revolution, and they've said that revolution of the earth causes seasonal changes. The amount of heat that a place receives on earth depends on the angle at which the sun's rays reach it. When a place receives vertical rays of the sun, the place gets hot. This is because the amount of heat in the direct vertical rays is concentrated on a small area, whereas the same amount of heat is spread over a large area if the rays of the sun is oblique. So because of the rotation of the earth, now this detailed explanation of how seasons take place, again I'll explain it to you earlier or later, and with the help of a diagram. So you just remember that revolution of the earth, the last paragraph, causes different seasons and the changing weather conditions due to difference in the heating of the earth. So remember that. Second is inclination of the axis and seasonal changes, that because the earth is tilted and inclined, we have seasons, but when one season changes into another, or one season goes away and the other season comes, the change is not abrupt. Suddenly it does not happen. Just like when you have day, you don't have night immediately, you have evening, then night. Okay, so this way the change is not abrupt. The next effect of revolution is the position of the earth, referred as perihelion and aphelion. So in the second paragraph, I have underlined the definition for you, what is perihelion and aphelion. Now you see the diagram 3.5 which is given below. Now you will see that the sun is in the mid position, the orbit of the earth is elliptical, and the movement of the earth is shown in red circles. So perihelion is given, which occurs on 3rd January, and you will see the distance between the sun and the earth is not much. So during revolution, when the earth is closest to the sun, this position is called perihelion, which occurs on 3rd January. And if you come in the same diagram on the left hand side, you will see aphelion, which occurs on 3rd or 4th July. And this is the position when the earth is farthest away from the sun. So aphelion starts with alphabet A, and then you can learn that when the sun is away from the earth is away from the sun on 3rd or 4th July. So these are the two dates you must remember, and the position of the earth, that on perihelion, which occurs on 3rd January, the sun is closest, and aphelion means away, the sun is farthest from the earth is farthest from the sun on July 3rd or 4th. Now the next thing they have given here is the effect of revolution is the creating of heat zones. Now if you remember in the second chapter of geographic grid, I had explained you in detail about the heat zones. So there the same repetition is there. So you just learn this, the torrid zone, which lies between equator and Tropic of Cancer and Tropic of Capricorn, and the sun rays are vertical here, and it is very, very hot over here. Then we have the temperate zone, which lies between Tropic of Cancer and Arctic Circle in the north, Tropic of Capricorn and Antarctic Circle in the south. And the sun rays over here are somewhat oblique, but this region has moderate climate. And the last zone is the frigid zone, which extends from the Arctic Circle to North Pole in the northern hemisphere, and Antarctic Circle and the South Pole in the southern hemisphere. And this region experiences extreme cold weather. Now we come to the important two terms, solstice and equinox, which is the summary of this whole chapter. Each time they were telling you, or we were reading, unequal length of day and night, revolution causes change in seasons, etc. Now we are going to come in detail explanation. So the lighted part of the earth is called the circle of illumination, and they've given you in this table below the difference between solstice and equinox. What is solstice? Now, solstice means, it is derived from a Latin word which means the standing still of the sun. It doesn't mean the sun is still, but when the earth is moving around the sun, it comes in such a position that either the northern hemisphere or the southern hemisphere faces the sun. And this happens twice a year. That is on June 21st in the northern hemisphere and December 22nd in the southern hemisphere. And they have mentioned in the first point, solstice refers to the time when the sun reaches its highest or lowest point in the sky at noon, resulting in the shortest and longest days of the year. So I've explained you the second, third first, and then the first point. Then we come to the term equinox. See, I'm not reading from the paragraph which is given over there, because the detail difference is given in the table. So you learn this table nicely. Now, equinox, the word equinox, the second point, you come to that first, we'll come to the definition. The word equinox means equal night. And at this time of the year, during equinox, the sun shines at the equator. It happens twice a year. On other latitude, it is shining only once. Tropic of Cancer, once a year. Tropic of Capricorn, once a year. But when it is moving, it shines on the equator twice, on March 21st and September 23rd. And this March 21st is the spring equinox, and September 23rd is your autumnal equinox. So you learned this table, the definition and the difference between your solstice and equinox. Now children, they have given you here the table which I have cancelled here, and the angle of incidence which I have also cut it out. And we come to cycle of seasons, which just now I was telling you that we'll explain that equinoxes and solstices are the positions of the earth with respect to the sun on the given fixed dates. That is June 21st and September 23rd. And then we have December 22nd and March 21st. So solstice occurs twice, that is June 21st and December 22nd. And equinoxes, we have March 21st and September 23rd. Now I am going to explain you the seasons, that how revolution of the earth causes change in season, and how when the season changes, how the duration of day and night, the length of day and night also changes. So just come to the last line of this paragraph, a cycle of seasons. There are 4 seasons: spring, summer, autumn and winter. And these 4 seasons are showing that there is no abrupt change from summer to winter. So we have summer, then we have spring, then we have winter, and then again we will have autumn. So we have the 4 seasons that they have given you here. So we don't have any abrupt change. Now the first thing they've mentioned you here is the position on 21st June. Now this is our summer solstice. It is summer solstice in the northern hemisphere. The sun rays fall vertically on the Tropic of Cancer. So the duration of sunlight or daytime increases as from 12 hours at the equator to 13 hours and 20 minutes. So you don't have to learn the duration. You just have to remember that this on June 21st, the solstice takes place in the northern hemisphere and the sun rays fall vertically over the equator. Now, at this time, beyond the Arctic Circle, the region experiences 24 hours of daylight. That means when the sun is shining over Tropic of Cancer, all the places from Tropic of Cancer till the Arctic Circle are experiencing their summers, and they have longer days and shorter nights. And beyond the Arctic Circle, because the Earth is tilted, it is inclined, all the places beyond the Arctic Circle will experience 24 hours of daylight, which is called the phenomena of the midnight sun. And Norway is called the land of the midnight sun because the sun is visible even during midnight, and it is at a very low height just above the horizon. But at that time, on June 21st, when there is summers in the northern hemisphere and we have longer days and shorter nights, at that time in the southern hemisphere, the Tropic of Cancer is not facing the sun. So that time the southern hemisphere experiences its winter with shorter days and longer nights. Then they have given you your position on 23rd September. Now, position on 23rd September, you have to just remember that it is the spring equinox. Sorry, this is on 23rd September. The sun is vertically overhead at the equator, and it is the autumn equinox. Sorry, this is the autumn equinox. Then we have position on 22nd December. Now, as the earth is moving around the sun after shining on equator, the position of the earth comes in such a manner that it shines over Tropic of Capricorn in the southern hemisphere. So the southern hemisphere now is facing the sun. So it will experience on 22nd December, the southern hemisphere will experience its summer. That is, they will have longer days and shorter nights. But at that time, the northern hemisphere will experience its winter. And then again they've given you position on 21st March. Now this is that as the earth is moving around the sun, the earth comes in such a position that it again shines on the equator, and that is called the spring equinox occurring on March 21st. Now this phenomena I am going to, children, explain you with the diagram now. Now this diagram over here is showing you the position of summer solstice. If you were not able to understand what I was explaining, now this diagram you will see that the earth is tilted in such a manner that when it is moving around the sun, the position of the earth comes in such a manner that Tropic of Cancer is inclined towards the sun. And by June 21st, the sun is directly over Tropic of Cancer. So at this time, all the places from Tropic of Cancer and the North Pole, they will be having their summer till the Arctic Circle, their summer with longer days and shorter nights. And the southern hemisphere, that is Tropic of Cancer, is away from the sun, and it is experiencing its winter on June 21st. So this is your summer solstice. Now this is your winter solstice, which occurs on December 21st or December 22nd. You can take any date. Now again, it is due to the movement of the earth around the sun. Now, in this, while the earth is moving around the sun, because of the inclination of the earth's axis, the earth comes in such a position that now the southern hemisphere faces the sun. So, all the places, now the sun is going to shine at Tropic of Capricorn on December 22nd or December 21st, and the southern hemisphere from Tropic of Capricorn to the Antarctic Circle will experience its summer, and the places from the Antarctic Circle to the South Pole will have its longer days, and they will have continuous daylight for 6 months. And on this day, the northern hemisphere, that is Tropic of Cancer, is away from the sun rays, so the northern hemisphere will experience its winter solstice. So on December 22nd, the southern hemisphere experiences its summer, but the northern hemisphere experiences its winter. So each time you will see when there is winter or summer solstice and the sun rays are falling on particular latitude, the duration of day and night is changing. When it is shining in the northern hemisphere, they have longer days and shorter nights. It is summer. And when it is shining in the southern hemisphere, they have the longer days and shorter nights, and the northern hemisphere is having the shorter day and longer night. So you will see that not only there is a change in the season from summer, and then there's a change in winter. So the revolution of the earth causes change in seasons. There's not one season prevailing throughout the year, as well as it is affecting the duration of day and night. Now, this diagram is the explanation of the whole chapter. Now, before I explain further on, now I'll explain you the equinox. Now, you will see that on June 20th, which is given here, June 21st, when the sun is over Tropic of Cancer and there is summer solstice, as the earth is moving around the sun, on September 23rd and or 22nd, both are acceptable, the sun shines over the equator, and this is called equinox. Remember, I explained you, when the sun is directly over the equator, it is equinox. All the places will have equal length of day and night except the poles, because they are far away. So this is the autumnal equinox. So there is no abrupt change from summer to winter. From summer solstice we come to autumn. And as the earth is moving, rotating, you will see, because the earth is inclined, now the southern hemisphere is facing the sun. So it is December 22nd and it is winter solstice, because the southern hemisphere is experiencing summer, but the winter is experienced in the northern hemisphere. Now after winter solstice, as the earth is moving, again the position of the earth comes in such a manner that the sun shines vertically over the equator on March 21st or March 20th, and this is called the spring or vernal equinox. So there is no abrupt change from one season to other. So these are the four major seasons that occurs due to the revolution of the earth around the sun. So I've explained you through this diagram the revolution of the earth and the position of the earth on various dates, and the change in seasons and the change in duration of day and night. And the last thing in this chapter is, children, we come to twilight in low and high latitude. So I have underlined, and you will just learn the definition of twilight and dawn. That is all you have to remember. The period of diffused light between sunset and complete darkness is called twilight. That means when before the night comes, gradually when the sun is going below the horizon, it is twilight. And the period between sunrise and full daylight is dawn. Abruptly the sun does not rise. So that faint light which occurs before the sun is above the horizon is called the dawn. Now they have given you the duration of twilight. The duration of twilight is large beyond 50-degree latitude and in polar regions. Now, why twilight period is greater? The diagram is given here because the earth is inclined, it is tilted. So, because the earth is tilted, the places which are facing the sun is lower in angle as it is sinking, but still, because the earth is inclined, those places can see the sun for a longer period of time. So the duration of twilight is greater as one moves away from the equator. This is because the period during which the refracted light is received at the equator is short, as the sun rises and sets in a vertical path there. On the other hand, in temperate latitudes, the period of this light is longer as the sun rises and sets in an oblique or slanting way. So it is much longer, this period of twilight is much longer at the poles. So children, I know the lesson was quite intense for you to understand, but go through the explanation which I have done, and especially the explanation of the solstice and the equinox which I have explained you through the diagram. Please learn that. Try to remember it, and if you have any problem, you can always upload your problem to me and I'll try to solve it out. Now, there are certain questions which I'll be uploading a little later along with the answers or the page numbers, so that it will help you and enable you to find the answers. So for today, this much only, children, and thank you so much, and please go through the lesson carefully. If you don't understand anything, you can see the video again and again. Thank you and have a good day.